So hello and welcome to Mixologist, the place on the internet thingy where you're not going to hear what you think I am going to say. And case in point, we've got for the first time in the channel, not in the shop because I've done another Rochester Quadrajet pre-channel, but for the first time in the channel, we're going to be doing a little bit of Rochester Quadrajet content. And the reason why I made that introduction is because you might think that I'll be kind of down on this sort of curves, criticizing it, saying it's quadra junk, quadra bog, don't use them, that kind of thing. And that is actually not correct. Why? Because yes, obviously if it was my own carb, my own car that I was running, I would probably put a Holley in, just because I got more spare parts, I find them easier to tune. But that doesn't mean that I think that Rochester Quadrajets are rubbish. In fact, quite the opposite. They do have some limitations which we're gonna go into in a bit, but I think that they are perfectly reasonable and very good carbs when used correctly. Yeah. So, for example, if you've got a just a production line, stock engine that originally came equipped with one of these, you're probably better off just leaving it on. Make sure it's obviously in good condition and it works fine. But apart from that, you will be better off just sticking to your Rochester Quadrajet, and the vehicle will work absolutely fine. Because let's say this sort of carb was used by General Motors in tons and tons of engines, and if it wouldn't have worked, they wouldn't have used it. So it does have a lot of things going for it, and that is something that we also need to acknowledge. So on this video, on this episode, what I'm going to do is I'm going to go through its main features. I'm going to be doing the disassembly of this particular unit, and what we're going to be doing is we're going to be doing a little bit of kind of comparison with the Holley Spreadbore, which is essentially kind of Holley's copy of the Rochester Quadrajet, well, how it came about and whatnot. Okay, so in terms of kind of what this unit is, as I've already said, this is kind of GM's main 4-barrel carb of the modern era. It's been installed in absolutely tons of GM products, though not exclusively though. Some GM products did come, some GM V8s did come from the factory with a Holley carb. But the vast majority of GM 4-barrel V8s came with one of these, and therefore it is quite a commonly available carb. And also in the US at least, it has quite a lot of support in terms of it's relatively easy to obtain spare parts. So that already is a plus for the Rochester Quadrajet. Now here in England, it's not as easy of obtaining spare parts for this car, I have to say, but hey, that's sometimes what happens. So what I'm gonna do is I'm gonna bring the camera a little bit closer, and I'm gonna show you what's the basic operation of this car before I start tearing into it. And then I'm going to show you once I do that, I'm going to show you some differences with the Holley Spreadbore, which is as I said, the copy of this. Okay, so the Rochester Quadrajet, first of all, the principle of operation of this carb is, I think this is the most important aspect to focus on the carb, because as you can see, it has the primaries compared to the secondary are really small. Yeah, and basically this carb, it operates like so, and it's, let's say it's a, whoops, sorry, it is a mechanical secondaries carb, but it's not as you think it works. Yeah, and I'm gonna go into that kind of in a minute. Yeah, but for the time being, what you need to bear in mind is that this carb is designed so the throttle the throttle opens about yay big. So for the primaries are designed to be quite small. This is two things. It gives you kind of more velocity of the charge through the manifold, better low speed torque, and also better fuel economy. Yeah, so you can run like big block engines on this, and for low loads, low speed, this throttle action is absolutely fine. But then what happens when you need more power at high RPMs? Well, that's when you get your really big ass secondaries opening and really like flooding the engine with fuel. And this is the principle of the Rochester Quadrajet, that you get a mixture of kind of economy here, and you get the potential for a lot of power to be produced. Yeah, so that's the basic principle of the carb. As you can see with the a difference you can see straight away is that obviously the mounting holes are quite different to what a Holley would be. So here's your typical like Holley, we've got this way, but it's the same. Your typical Holley base plate holes, and you can see that none of the holes match, basically. So these carbs are well and truly incompatible, and most Holleys really of the square bore variety, which this is, have all the holes the same thing, which this one obviously hasn't. So that's a difference you can see straight away in there. Also the Rochester Quadrajet is built in a slightly different logic from the Holley carb, in that basically the fuel bowl is this armature in here in the middle, and it's covered by this top here, and the accelerator pump, it doesn't work for like from a diaphragm. It is this plunger that you can see here, that we'll see it a little bit better when we turn to the unit, when we start disassembling the unit. And the final thing about the operation of the carb, remember that I said that it wasn't like a double pumper. Well, because when you open the secondaries on the other side, this air flap essentially opens, activated by demand from the engine. So it's not necessarily that the secondaries open and this is going to open as well. So there is some sort of progression to how this carb opens, and therefore that's what sometimes causes the Quadrajet to bog. If this kind of air vent is not working properly, this can cause issues with the carb. However, and as I said before, it's not that it is a bad design. If it's working properly and you got a GM car that came equipped with them, they're a real winner, and they're a very good performer. They got good fuel economy and good power overall. So don't overlook these carbs in any way. So now what we're going to be doing is we're going to start the disassembly process, and we'll check a bit more all in the kind of inside of the carb and kind of how it works. Okay, so before I start with any other disassembly processes, let's work out, it doesn't take a genius to work out why this unit was sparked. So look at this. This is probably fuel and water mixing in some capacity, and this is what is the equivalent of the fuel bowl in a Holley kind of context, and this is really not good. So therefore this is probably the reason why this unit just wasn't working anymore. Look at the state. Look at the state of this as well. So this clearly isn't very good. Okay, so now that I've got the carb in bits here, I can give you an explanation about how does the unit kind of actually works, and let's try to discern how each component works. Why is it different to some Holley carbs, and therefore I'm gonna do a comparison, a kind of side-by-side comparison. But for the time being, let's focus on how the Quadrajet actually works and all the different kind of systems that you've got. So I have to bring you a little bit closer to start the segment. All right, well, let's say the fuel comes in through this fuel inlet that you've got here, and there is a kind of needle and seat assembly which is there. Obviously it's got the needle, I've taken it out, but basically that is your kind of fuel control level. You've got this float, and so far the only thing you've done is like fill the bowl and whatnot. So in terms of idle fueling, you've got your idle mixture screws, which are these. They are incorporated into the base plate, so they go like so, and you obviously screw them in or out, and that's what determines your idle fueling, and they go through that hole that you can see right there. Yeah, so that's your idle circuit. So now let's think about the progression and acceleration circuits. So acceleration is very simple. You've got this kind of plunger type that basically goes like so, and if it was new, basically it has this lever at the top that goes like so, and basically pushes this plunger in like that, and that's what generates a squirt of fuel. Yeah, that's your acceleration fueling that is done with one of these plunger type systems, which is okay. But then let's think of the primary. Yeah, so let me show you. So you've got the primary, and you start kind of accelerating about yay that you've got only the primaries open and not the secondaries. Yeah, so it's still only this side of the carb working. Okay, so there is a piston here that goes yay, and basically what this piston does is the same job as the power valve on a Holley carb does, because this is your power enrichment system. Yeah, so in normal circumstances, what you've got is you've got this piston that is being pulled down by vacuum in the engine, and therefore this piston is going to be down, and it has this spring here like so that basically tries to push the piston up, but generally the piston will be down. So therefore this array, if you want, goes on top of the piston like so. So therefore what happens is that you've got these needles. Yeah, so what do the needles do? The needles basically, and let me see if you can see it better like that with the light, the needles essentially cover the jets. Let's see if I can do it there. Pretty much, yeah, there we go. So you see, so at full vacuum, well, what you're having there is that these needles are covering the jets, and therefore what they're doing essentially is making the jet smaller. It's a bit like if I get like a big orifice like this and I try and kind of jam in this, yeah? So now I'm creating a restriction for that orifice. It's the same principle at work here with this. So therefore, as a vacuum starts dropping off, this spring starts overcoming this piston, and this starts going up. And as you can see, you start exposing more of the jet, therefore putting more fueling in. And that's kind of how it works, yeah, when the vacuum starts dropping. And a similar thing occurs when you start, so when you go like this, when you give it like the full bananas and both throttles are open fully, yeah, that's on the high load, what happens is something similar. So you have got in there, I'm pointing out there and there, two essentially jets that are covered in the same way with these needles here. And if you can see now, hopefully, let's see if I can make this on camera. You've got this flapper valves that basically they open to let air in, and when they are opening to let air in, what happens is that these needles here, they go up, and therefore they expose more of the jet in the same way that happens in the primary side, yeah. So when the flaps are fully open, those jets, those needles are out of the jets, and therefore creating a richer mixture into the system, into the unit. So therefore that's essentially the basic operation of a Rochester Quadrajet. So now in this segment, what I'm going to do is I'm going to be comparing the Rochester Quadrajet with the Holley equivalent, which is called the Holley Spreadbore, which I've got here in bits. So I'm going to do a bit of a kind of side-by-side comparison of the units and how do they work. So let's again bring the camera round, this time on the other side. As you can see, the Holley Spreadbore kind of has the same logic of relatively small primaries and large secondaries, which is the same as here. And if I put the base plates like so, you can see that it is entirely compatible one with the other. So they got the same manifold holes, one of the other. In fact, this one has got a couple of extra holes, but it doesn't really matter. And I think the reason that this is like this is because Holley wanted to get into the act and trying to kind of get into the aftermarket, so that you could buy a Holley carb as a replacement for your Rochester Quadrajet to put in your GM vehicle, and therefore you will buying a Holley product, that kind of thing. So I think it was a play, for the refurb or for the spare parts market. Let's look at the idle circuit. So obviously the idle circuit in the Rochester Quadrajet is incorporated into the base plate, as I showed you there. Whilst in a Holley you would have it incorporated into a metering block. So the Holley Spreadbore uses the metering block system and uses kind of the Holley style bowls, be it the cathedral bowls or a modified bowl for the whole thing. And obviously you would have your a metering plate and a fuel bowl on the primary side, and you may have the same thing on the other side, yeah. So you would have two fuel bowls in a Holley Spreadbore that are keeping your fuel. And that starts already to be a big difference in performance between the two carbs. Why? Because if you look at your Rochester Quadrajet, and if I put the float there, you can see that the fuel, like the fuel bowl, is this area here, and a little bit of this area around here and here, but some of it is taken by the needles and whatnot. So actually, the Rochester Quadrajet, for what it is, has a relatively much smaller fuel bowl than the Holley, because the Holley, even though this fuel bowl might be slightly smaller in capacity than this, it's still got two of them. So therefore, the Holley has much more fuel than the Rochester Quadrajet. And that's what I said is one of the limitations of this carb, that this fuel bowl is a bit too small, yeah, for the carb. If you want it for really high performance like racing applications, I think a Holley is better because it has that much more capacity of fueling. Obviously, remember what I explained about the needles and how does the Rochester Quadrajet respond to increases in load, i.e. in vacuum. Then you do it via these needles, whilst the Holley Spreadbore, what it does is uses the famous power valve, and therefore you got these passages which are the extra fueling for the increase. So therefore, and you have got in terms of Holley, you can have carbs that are actuated via vacuum, or you can have mechanical secondaries carb. So actually, and as you can see there, this is like the top. So Holley has there is one advantage that the Rochester Quadrajet has over the Holley, which is that sometimes it can be slightly better for leaks. Why? Because if you think about it, the fuel lives kind of inside this component, and provided that these things don't leak, it means that the unit is very unlikely to leak unless it's got problems with the fuel level becomes too big. Whilst in Holley carbs, what happens is that you've got a gasket here between the metering block and the unit, like so, and then you've got yet another gasket that goes there. So whenever you've got, more gaskets, you've got potentially more failure points. So that in a sense is a disadvantage of the Holley, and you've got an advantage for the Rochester Quadrajet. However, that advantage is slightly negated by the fact that a Holley is relatively easier to clean. Why? Because you can take the fuel bowl like so, just clean it up with carb cleaner or whatnot, just bang it back on, and away you go. Whilst if you've got a Rochester Quadrajet, in order to clean this, it's much more difficult. If you want to just kind of spray with carb cleaner, you can, which is what I've done here. But in order to really clean it, you probably need to take it out of the engine. Whilst the Holley, you can clean it a little bit kind of more efficiently, at least in my opinion. Okay, so I hope you kind of got something out of it. This is a very basic introduction about the Rochester Quadrajet, the difference with some of Holley products, and I hope you enjoyed this. If you've got any comments or questions, just put it in the comments, and if not, I'll see you in the next episode.